Here is something most students never get shown. The distance formula you memorize is not some separate rule to learn. It is the Pythagorean theorem wearing a disguise, and today we are going to pull back the curtain and find the right triangle hiding inside it. Let's place 2 points on a grid, point 1 at x sub 1, y sub 1, and point 2 at x sub 2, y sub 2. We'll show this both as a flat 2D grid and as a tilted 3D view, so you can see the same 2 points from another angle. Now watch what happens when we drop a horizontal line from one point and a vertical line from the other until they meet at a corner. A right triangle appears naturally, with one leg running along the x direction and the other leg running along the y direction. The horizontal leg has length, the absolute value of x sub 2 minus x sub 1. The vertical leg has length, the absolute value of y sub 2 minus y sub 1. And the slanted line connecting our original 2 points is the hypotenuse, which is exactly the distance we want to find. Since this is a right triangle, Pythagoras tells us straight away that distance squared equals open bracket x sub 2 minus x sub 1 close bracket squared plus open bracket y sub 2 minus y sub 1 close bracket squared. Taking the square root of both sides gives us d equals the square root of open bracket x sub 2 minus x sub 1 close bracket squared plus open bracket y sub 2 minus y sub 1 close bracket squared. That is the entire distance formula, built from nothing more than 2 legs and a hypotenuse. Before we move on, pause for a moment and make a prediction. If you wanted to walk to the exact midpoint of that slanted segment, what fraction of the horizontal leg and what fraction of the vertical leg would you need to travel? Keep that guess in mind. Here is the reveal. Draw a smaller right triangle from point 1 to the midpoint, sitting inside the big triangle we already built. Because the midpoint sits exactly halfway along the hypotenuse, similar triangles tell us this smaller triangle is a scaled down copy of the big one, scaled by exactly 1/2. So it must reach exactly halfway along the horizontal leg and exactly halfway along the vertical leg too. Halfway along the horizontal leg means starting at x sub 1 and adding half of x sub 2 minus x sub 1, which simplifies to open bracket x sub 1 plus x sub 2 close bracket divided by 2. The same reasoning on the vertical leg gives open bracket y sub 1 plus y sub 2 close bracket divided by 2. So the midpoint is simply the average of the 2 x coordinates and the average of the 2 y coordinates. And now we can see exactly why that averaging rule works geometrically. Let's check both formulas with real numbers. Take point 1 at 3, 2 and point 2 at 7, 5. For the distance, we compute d equals the square root of open bracket 7 minus 3 close bracket squared plus open bracket 5 minus 2 close bracket squared, which is the square root of 4 squared plus 3 squared equals the square root of 16 plus 9 equals the square root of 25 equals 5. Notice there are no sign errors here, since squaring the differences makes both legs positive regardless of which point we subtracted from which. For the midpoint, we compute open bracket 3 plus 7 close bracket divided by 2, comma open bracket 2 plus 5 close bracket divided by 2, which gives us 5, 3.5. You can check on the grid in both the 2D and 3D views that this point sits exactly halfway along the segment, confirming our similar triangles argument. So there you have it, the distance formula and the midpoint formula both derived directly from one right triangle and the Pythagorean theorem. If this helped the ideas click into place, like and subscribe, and stick around, because next time we will use this same triangle to derive the equation of a circle.